Good day and welcome to today's class. Today we are talking about the definite and Riemann or Riemann integral. Definite or Riemann integral. The definite or Riemann integral is used to find or calculate the area is used to calculate the area under a given curve. The area under a given curve. There are two ways of using the definite or the Riemann integral. The first one is using the limit of sum, or which we call the Riemann sum. We have talked so much on Riemann sum. You can go back and look at the previous videos. And the next one is using the antiderivative. Antiderivative. But for today's class, you want to perform Riemann integral using limit of sums. Using limit of sums. Recall that our Riemann sum, which we also use as area under the curve, is what the summation as I moves from 1 to n of f of t sub I delta x, where our delta x is the width of the subintervals and our t sub I are the tags or sample points in each of the subintervals. Now, to approximate Riemann integral using Riemann sum, remember in the last video when we were finding the lower and upper Riemann sum, we got to a point I told us to do what? We are told to take the limit as n tends to infinity. As n tends to infinity. So in order to approximate our Riemann, to get our Riemann integral now, we take the limit. Let's write that down. Take the limit of the Riemann sum as the norm of the partition. The norm of the partition approaches 0. Approaches 0. Therefore, the area under the curve now becomes what? Limit as the norm approaches 0 of what? Of the summation of I as I move from 1 to n of f of t sub I delta x. This expression is called the definite or the Riemann integral. This expression is called the definite or Riemann integral. the definite or the Riemann integral. And so we can now say it this way. Therefore, we can say it this way. The definite or Riemann integral of a function f of x from a to b, denoted as what? The integral. You will recall from your previous math classes that sign as the sign of integral of f of x dx. And remember, we have said it is this: the limit as the norm of the partition tends to 0 of what? The summation as I move from 1 to n of f of t sub I delta x. And that is the same thing as the limit as n tends to infinity of summation from I equals 1 to n of f of x sub I delta x. It is also the same thing as the limit as delta x tends to 0 of summation as I moves from 1 to n of f of x sub I delta x. In the next class, we will look at how to use the Riemann integral to evaluate or calculate the area under a given curve. See you in the next class. Have a beautiful day and God bless you.